The examples in this video go with section 6.3, the law of cosines. Example 1, solve triangle PIG with angle I equal to 61 degrees, side G equal to 19, and P equal to 28. Round the measures of the unknown side and angles to one decimal place. All right, first thing we should do is let's draw a picture of our triangle so we can get an idea of what it looks like. And there we go. Here's angle P, angle I, and angle G. Angle I up here, 61. Side P over here is given to me to be 28. And side G over here is given to me to be 19. And we need side I. So we're looking for angle P, angle G, and side I. All right, this is a side angle side situation, and so it calls for the law of cosines. And what I'm going to do is I'm going to use the formula that side I squared is equal to side P squared plus side G squared minus 2 times P times G times the cosine of angle I. Let's see what we get. All right, we have I squared equal to P squared plus G squared minus 2 times P times G times the cosine of angle I. Now all of this we can actually put into the calculator at one time and figure out what I squared is actually equal to. Let's be sure that we're in degrees though for that cosine 61. And this is giving me 629.2, and then we'll need to square root both sides. And we're going to take the positive square root here because the negative square root is not going to make sense as we're measuring a distance or a side length. All right, let's square root this. And I'm getting 25.1. So side I is going to be 25.1. Now, from this point, you now have the option to use the law of cosines again to find angle P or angle G. Or you can use the law of sines, because now that we know side I right here, we have an angle side-side situation or an angle side-side situation this way. The law of sines you can use. I don't recommend it because that angle side-side situation is the one that gives you that ambiguous case. So maybe there's not a triangle, maybe there's one triangle, maybe there's two. I mean, this is a law of cosines problem, so there's only going to be one triangle. And so my personal preference is if you start solving a problem with the law of cosines, stick with it all the way through the problem. So what I'm going to do now is I'm going to use the law of cosines and that side I that we just found, and I'm going to find angle P. All right, and since I'm going to find angle P, I'm going to use the formula that P squared is equal to I squared plus G squared minus 2 times I times G times the cosine of angle P. And that's going to be what we're looking for right there. Okay, let's set this up. We have P squared equal to I squared, this is the side we just found, plus G squared minus 2 times I times G times the cosine of angle P. Now, like last time, we were able to throw all this in the calculator at one time. It's because we had numerical values for everything. Here we actually don't. Now what I'm going to do is I'm going to figure this part out in the calculator. I'm going to figure this part out in the calculator. And I'm going to figure this part out in the calculator. So I'm going to do it in 3 separate parts. And here's what I get from figuring out each of these three things. 28 squared is 784. 25.1 squared plus 19 squared gives me 991.01. And then 2 times 25.1 times 19 is going to give me 953.8. And because the variable is located right here, we're not actually able to combine these two terms right here. They are not like terms. And so we're going to solve this like a regular equation. And I'm going to start with moving this 991.01 to the other side with the 784. And this gives me negative 207.01. And then it will be equal to negative 953.8 times the cosine of p. Again, here's my variable back here, so I need to get rid of this negative 953, and also I need to get rid of this cosine. I'm going to have to do it in 2 steps. All right, so the first thing I'm going to do is I'm going to divide away this negative 953.8 because it is currently being multiplied by that cosine of p. Now I'm hoping that when I do this division, I get a number that's between positive and negative 1. Because if I don't, then I've got a problem. And this is going to give me 0.2170, which is now equal to the cosine of angle P. So if the cosine of angle P is equal to 0.2170, it must be true that angle P is equal to the inverse cosine of 0.2170. And when we put that in the calculator, we will know what angle P is. And let's round that off to 1 decimal place. And that's giving me 77.5 degrees. All right, all that's left to do is to get angle G right here. And I already know angle I and angle P. So I'm going to use what I know about triangles and the fact that all the angles add up to 180 degrees. And I'm going to find angle G by subtracting away angle P and angle I. All right, so angle G is going to be 180 minus angle P that we just found minus angle I, which was given to me. Put that in the box there. Okay, all right, let's put this in the calculator. And this is giving me 41.5 degrees. And now my triangle is solved. Example 2, solve triangle RAT with side R equal to 62, side A equal to 48, and side T equal to 41. Round the measures of the angles to the nearest tenth of a degree. Okay, let's take a look at our triangle first. We'll put angle R down here, angle A up here, and angle T over here. Side R we know is equal to 62. Side A is equal to 48. And side T is equal to 41. This is a side-side-side situation. Because we know all three sides, we're going to have to use the law of cosines. And I guess I'll start with finding out what angle R is. I'm going to use the formula R squared is equal to A squared plus T squared minus 2 times A times T times the cosine of angle R. Okay, let's set this up. R squared is equal to A squared plus T squared minus 2 times A times T times the cosine of angle R. Okay, now just like the previous problem, we're going to have to do this in 3 separate parts because my variable is back here. I can't combine all of this with all of this right here because this is attached to the variable that is not. All right, so let's put in the calculator and simplify each of these 3 terms. And here's what the calculator gives me when I square the 62 and when I square the 48 and 41 and add them together, and then when I multiply 2, 48, and 41 together. All right, we're going to solve this like an equation. I'm going to start by moving this 3,985 to the other side with the 3,844. And this gives me negative 141, which is equal to negative 3,936 times the cosine of r. All right, we'll divide away this coefficient here, negative 3936. And remember, when I divide it over here, I want to get a number that's between negative 1 and positive 1 so that I can do the inverse cosine. If I don't get a number between negative 1 and positive 1, then our triangle doesn't exist. And this gives me 0.0358. So if the cosine of r is equal to 0.0358, it must be true that angle r is equal to the inverse cosine of 0.0358. And when we put this in the calculator, be sure you're in degrees, we'll know what angle r is equal to. And it looks like r is equal to 87.9. All right, so angle r, 87.9 degrees. All right, so there's one of my angles solved. Now I have to get another one of my angles, and I can choose between whether I want to do A or whether I want to do T. I think I'm going to want to do angle A. And I'm picking angle A because I can use the law of sines here because I have an angle side angle situation here. So I'm not in a position where I'm going to get that ambiguous case and have to worry about if there's two triangles or not. Or I can use the law of cosines and I don't have to worry about whether there's a second triangle formed or not. So I'm going to go with my original plan, which was if you start with the law of cosines, keep going with it. So if I want to find angle A, then I'm going to use the formula a squared is equal to r squared plus t squared minus 2 times r times t times the cosine of angle A. Notice that the side and the angle are on opposite sides of the equal sign. Okay, side A and angle A, they're on opposite sides of the equal sign here. All right, let's look that up. We're going to have a squared equal to r squared plus t squared minus 2 times r times t times the cosine of angle A. And I'm going to have to solve this equation similarly to the way I solved this one over here. I'm going to be putting this in the calculator, and I'm going to be putting these in the calculator, and then I'm going to be putting these in the calculator, and it's all because my variable is back here. We can't combine these because they're not like terms. And here's what I get after I've squared the 48 and squared the 62 and the 41 and then added them together and then multiplied the 2, the 62, and the 41. All right, let's keep going. We need to move this 5,525 over here to the other side and subtract those. And we know on the other side we're going to end up with negative 5,084 times the cosine of A. And over here, we're going to end up with a negative number. Let's put it in the calculator and see. And it gives me negative 3231. All right, now we'll need to divide away this coefficient on both sides. And again, we want to make sure that when I do this division, I get a number over here that's between positive 1 and negative 1 so that I can find its inverse cosine. And I'm getting 0.6355. Now, All the problems that we've done so far have given us a positive number right here, so that when we're doing the inverse cosine, we are taking the inverse cosine of a positive number. Please know that you can get a negative number over there and we can take the inverse cosine of it. I just need to make sure that whatever this number is, if it's negative, it's going to be bigger than -1. That way I can take the inverse cosine of it. And this is telling me that I get 50.5 degrees for angle A. Okay, angle T, we're just going to use what we know about triangles, the fact that they add up to 180, and that's going to give us our angle T. All right, so angle T is going to be equal to 180 minus angle R, which was 87.9, minus angle A, which was 50.5, and that gives us 41.6. Okay. Now, we could have used the law of cosines one more time and figured out that angle, but it was a little bit quicker to try and figure it out using the fact that all the angles in a triangle add up to 180 degrees. But we are finished. We have angle R, angle A, and angle T. This triangle is solved. Example 3, a Coast Guard ship on a routine training run leaves its base at 18 knots for 3 hours on a course of north 17 degrees west. 3 hours later, a distress call comes in from a cargo ship located 180 nautical miles from base at a bearing of north 48 degrees east. Part A, how far is the Coast Guard ship from the cargo ship round to the nearest tenth of a nautical mile? Okay, let's do part A and then we'll come back and look at part B. And we need to draw the picture first. Okay, what's going on here is we have a base located right here. And the Coast Guard ship is going to leave the base and is going to head off in this direction. And after 3 hours, this angle is going to be 17 degrees. He will be some distance away from the base. Now, you've got to figure out what that is, but that's okay. We have enough information to do that. Okay, then we have a cargo ship leaving that's going 48 degrees, or north 48 degrees east, heading out this way. Now, we want to make it longer than this because the cargo ship has actually gone further than the Coast Guard ship, and I'll tell you why we know that in just a minute. So let's just make this pretty long. We'll stop the cargo ship right here, and we are going to be looking for this side right here, which I'm going to call D for distance. Okay? Oh, and we know this angle right here is 48. Okay, now I said we had enough information to get this side right here, and we do, because we have a formula that said that the distance traveled is equal to the rate they're traveling times the time it takes them to get there. And in this case, we know that the Coast Guard ship is traveling at this rate, 18 knots, and here's the time for 3 hours. So we can figure out what that side is by multiplying 18 times 3. And that's going to give me 54. All right, so what that tells me is this side right here is going to measure 54. And this side was given to me to be 180 in my problem right here. And so now you can see we have a side angle side situation where we're trying to figure out the other side back over here. All right, so our formula is going to be d squared is equal to c squared plus s squared minus 2 times times c times s times the cosine. Now our angle is actually going to go from here all the way across. And so our angle is 17 plus 48, or 65 degrees. All right. And now, because my variable is located over here on the left, I can put all this in the calculator at one time. And this is going to give me 27,100.3. So let's square root both sides. And we'll be taking the positive square root here. And it turns out that distance is 164.6, and these are nautical miles. Okay, so now what I'm going to do is I'm going to take off this side right here, because now we know what it's equal to. Oops. Let's try that again. All right. Now let's go look at part B for the problem, because part A is done. Part B, what bearing should the Coast Guard ship follow to reach the cargo ship and round to the nearest tenth of a degree? All right, let's go back to our picture. So now the Coast Guard ship is going to have to travel this direction to get up here to the cargo ship to try and help them. All right, so we need to figure out the bearing that they're going to need to travel. And I've got my north-south line here. And we are actually going to be looking for this angle right here, theta. Okay. Now, things that we know. First of all, I know that this angle right here actually measures 17. And I know that because I have some parallel lines here and here, and these are alternate interior angles. Okay? This angle right here I can get using the law of cosines because it's all inside the triangle. And when we're finished, I should be able to add 17 plus whatever this angle is, plus whatever this angle is, and that'll give me 180. And I know that because I have a straight angle here which measures 180 degrees. Okay. All right, so let's see if we can find this angle in here. And, well, this was angle C, wasn't it? Okay, so we'll just call this angle C right here. All right. We're going to set this up. We're going to have C squared equal to S squared plus B squared minus 2 times S times B times the cosine of angle C over there. All right, this is one of those problems where I'm going to have to do this in 3 steps because my variable is over here. So we'll do this in the calculator, we'll do this in the calculator, and then we'll do this in the calculator. And after putting those all into the calculator, this is what I get. 32,400 is equal to 30,009.16 minus 17,776.8 times the cosine of C. All right, let's move this 30,009.16 to the other side. Okay, that's going to give me 2390.84, and this is equal to negative 17,776.8 times the cosine of C. We'll need to divide out this coefficient right here. And whatever we get, we want to be a number between positive 1 and negative 1 so that I can take the inverse cosine. And this gives me negative 0.1345. All right, so if the cosine of angle C is equal to negative 0.1345, it must be true that angle C is equal to the inverse cosine of negative 0.1345. that means angle C, and be sure you're in degrees when you find this, is going to give me 97.7 degrees. Alright, let's look back up here at the picture. We know this angle right here now. We just found it. And it is 97.7. Alright, now remember what I said. I have a straight angle right here. And I know this angle in here is 17. Now we know from here to here is 97.7. Now all I need to do is figure out this angle right here, and then I can tell what the bearing is. Well, because it's a straight angle, these three angles right here should add up to 180 degrees. Alright, so that means angle theta is going to be equal to 180 minus 17 minus 97.7. And that's going to give me 65.3 degrees. Okay, so the bearing is going to be 65.3 degrees. Now the ship is going to have to be traveling north and east. So the bearing will be north 65.3 degrees east. Example 4, find the area of a triangle with side lengths C equals 15.4 meters, A is equal to 22.6 meters, and R is equal to 26 meters. We're going to round to the nearest square meter. All right, we're going to use Heron's formula for this, or some people pronounce it Heron. I'm actually going to draw the triangle first before we go and find the area of it. So we have triangle CAR, side C is 15.4, side A is 22.6, and side R is 26. First thing we need to do is find out what the semi-perimeter is. And remember, that's going to be half of the sum of the sides. So 26 plus 15.4 plus 22.6. Let's put that in the calculator. And that's going to give me 32. All right. So now we're ready to put it into the formula. The area is going to be the semi-perimeter times the semi-perimeter minus each of the three sides there. Okay, so we're going to have 32 times 32 minus 26 times 32 minus 15.4 times 32 minus 22.6. And then we want to square root all of this. All right, let's put this in the calculator. And rounding to the nearest square meter is going to give me 173 meters squared.